CPU manufacturing begins with silicon purification to an incredible 99.9999% purity. This highly purified silicon is melted and grown into a single crystal cylindrical ingot. The silicon ingot is then sliced into thin wafers, approximately 300 millimeters in diameter and less than 1 millimeter thick. A diamond saw cuts the ingot with extreme precision. The surface must be perfectly flat and free of any imperfections. Photolithography uses light to transfer circuit patterns onto the wafer. A light source projects through a mask containing the circuit design. This process uses a light-sensitive chemical coating on the wafer. The light causes a chemical reaction, allowing specific areas to be etched away, creating circuit features as small as 5 nanometers. CPU manufacturing requires building multiple circuit layers. We start with the silicon substrate. Next, we add the metal interconnect through another round of photolithography and deposition. Next, we add the dielectric insulator through another round of photolithography and deposition. Next, we add the transistor gates through another round of photolithography and deposition. Next, we add the upper metal layer through another round of photolithography and deposition. Modern CPUs can have more than 15 layers of circuitry. Each layer must align perfectly with the ones below it, with precision measured in nanometers. Transistors are created by a process called doping, where impurities are added to specific regions of silicon to change its electrical properties. A transistor has 3 main parts: the source, the drain, and the gate. The source and drain regions are doped with elements like phosphorus or boron. Doping creates either N-type or P-type semiconductor regions. Modern CPUs contain billions of transistors, with the latest 5-nanometer process packing about 170 million transistors per square millimeter. After all layers are completed, the wafer contains hundreds of individual chips, called dies. These are separated by cutting along the grid lines. Each die undergoes rigorous electrical testing. Defective dies are marked and discarded. The percentage of functioning dies, called the yield rate, significantly impacts the final cost of processors. The final step is packaging, where the silicon die is mounted onto a substrate and encased in a protective package with pins or contacts for connecting to the motherboard. Modern CPUs include heat spreaders to manage thermal output and use different socket types like LGA or PGA. The packaging is specifically designed to handle the CPU's thermal and electrical requirements. The entire CPU manufacturing process takes place in ultra-clean rooms to prevent contamination. These clean rooms are classified as class 1 to 10, meaning they have only 1 to 10 particles per cubic foot of air, over 1,000 times cleaner than hospital operating rooms. Workers must wear full-body bunny suits to prevent contamination. Temperature, humidity, and vibration are precisely controlled. A modern semiconductor fabrication facility costs between $10 and $20 billion to build, making CPU manufacturing one of the most expensive and technically complex manufacturing processes in the world.